I'd like to welcome to, again, a Science Cafe. It's great. Appreciate you taking time out during basketball season here to see Campus Light. And I guess first off, I'm Paul Adams. I'm Director of the Science Math Education Institute, and several other things, but that's all I am for this. That works out well. And it's always great to find people from Fort Hays who are doing some interesting work to share with the public, and we appreciate you taking the time to be here. And I'm going to be sure I try to get it. Dr. Ahami Amadar.
That's
and I got
me.
it right. There we go. Who's an instructor at the FHSU Biological Sciences. And I've got to see a lot of people have commented on the picture that they provided, a little cat behind jail bars. So we'll hopefully find out.
We might see that cat again.
And so with that,
Keep an eye out.
thank you very much, and we'll turn it over.
Well, thank you everyone for coming. Hopefully everybody can hear me okay. We had a little bit of mic difficulties. So today's talk is all about stress. I think this is something that probably most people are at least somewhat familiar with. I think maybe a little bit. And you know, I tend to think about stress a lot because I study it in my research. So I actually do research on animal behavior. I study physiology, that's how the body works. And I do this using birds. So there's gonna be a few bird pictures in this presentation. So I look at things like, okay, what happens to birds? What happens in their physiology when they're stressed? In what ways does that manifest itself in other parts of life? And what's interesting is that we can kind of broaden this out and think about other animals with these aspects, including humans. I know sometimes we kind of separate ourselves like animals and humans, but we're really animals. We're animals like all other animals, and we experience stress. And we experience stress the way all other animals do. So part of my motivation for giving this talk is, okay, I study stress, I think about it a lot, I teach about it in some of my classes. I may as well just kind of go, borderline obsessive and do a whole presentation about it. So that's what we're doing. So, stress. Has anybody here ever experienced stress in their life? Let me see. Maybe a couple people, once in a while, some more than others, yeah. This is something that we experience on the daily. It's a regular part of our lives. And there's a number of ways that it occurs. We have stress in our family lives. We have stress just trying to get from place to place. I've got a couple students here. I know they feel stress every now and then, sometimes. We feel stress at work. We feel stress on the way to work, especially today when it was really slippery out and there was like snow graphite coating the roads and everything. So we experience stress a lot, and what's really interesting is that different people may differ in how they cope with stress too. Different things stress us out, different amounts of workloads, caring for kids, all these things, different amounts of these things stress out different people. We have different coping levels. And one thing that I want to kind of think about throughout this talk and have you all think about a little bit throughout this talk is stress bad? Is stress a bad thing? It gets kind of a bad rap, right? We hear about it, it's got really negative connotations, but is it bad? So just kind of keep that in mind throughout the rest of the talk, just something we're gonna think about a little bit. So when you think about, okay, what stress is, what is it? Before we talk about what stress is, we have to first think about what stress is not. So our bodies tend to try to be a sort of an equilibrium level. There's a certain level where our bodies work best. We don't want to be too cold. We don't want to be too hungry. We don't want to be too thirsty. We've got sort of this equilibrium level where we operate best. And that's called homeostasis. This is sort of our equilibrium level. If you shift out of homeostasis, your body tries to bring you right back. That's homeostasis. This is something you hear in nearly every biology class, right, Carrie? So that's kind of the equilibrium level. What stress is, and when I say stress, I mean physiological stress. So the things that stress us out have effects on our bodies. And what stress is, very simply, what it is just anything that shifts us out of that equilibrium range, anything that kind of takes us out of that equilibrium. And this can be anything. It can be anything. Would anybody like to share some things that stress them out? Or some things that you know that stress people out? Anybody like to share? Brooks, what stresses you out? Math. That's fair.
I think you missed what I was doing there.
That's another one. Anybody else?
Maybe all kinds of physical stresses.
All kinds of physical stresses, yeah. Worry, yeah, worrying about things. What kinds of things do we worry about? Say again?
My sick dog.
You're sick? Oh, I would worry about my dog if he was sick too. Yeah, definitely. Did you raise your hand, David?
Snowy roads.
Snowy roads. Yes. Do you want to share some of y'all's stresses?
My first time teaching.
Ooh, yes. That is a very big stressor. Yeah. Yeah, so these are all things that I think most people would be like, this is stressful. Physical health, having to take care of little miniature people, having to take care of little canines, having to do something new that you haven't done before, you're not really sure how that's going to be received. Yeah, these are all very stressful situations. And what's really interesting about stress is that even just the perception of not being in control of a situation can cause a person's stress response to start ramping up. Even just the perception of not having control of the situation causes us to kind of, go a little bit crazy, get a little bit agitated. So, thinking about physiological stress, there's a few components of stress, a few ways that it happens. And one of the most important ways, one of the most major components of stress, of our stress response, is something called the hypothalamic pituitary adrenal axis. It's a bit of a mouthful, and you're going to get quizzed on it later. Not really. The hypothalamic pituitary adrenal axis. So it's a lot, it's all these big words, things like that, but I'm going to kind of walk you through it with the help of me. So in this axis, hypothalamic pituitary adrenal axis, here we go. So in your brain, there's a couple of important structures in there. We've got a structure called the hypothalamus and a structure called the pituitary. Seems pretty obvious kind of given the name of this axis. The hypothalamus and the pituitary talk to each other all the time. They're always communicating with one another. And in fact, the hypothalamus, kind of think of that as being like this lookout. It's always taking stock of what's going on. It's taking stock of not only what's going on inside your body, but what's going on outside your body. Is it really cold out? Better start shivering. Am I really thirsty? Let's activate our kind of thirst response, our behavior that we want to go drink water. So it's always taking stock of what's going on inside your body and outside your body. Now, when you experience a stressor, and a stressor can be anything. We just had a room full of stressors that we talked about. When you experience a stressor, what happens is the hypothalamus sends a little signal down to the pituitary. The pituitary then sends a signal all the way down to your adrenal glands. Your adrenal glands, if you take your hands, put them on the backs of your hips like that, that's about where your adrenal glands are. They sit right on top of the kidneys. Your hypothalamus and pituitary deep inside your brain, I can't really point that out as well, but they're there, trust me, they're in there. But we get this message sent to the adrenal glands. The adrenal glands receive this message from the pituitary, and in turn, they produce something called cortisol. Cortisol is a hormone. Real life, genuine, 21 carbon cortisol. That is what it looks like. Has anybody heard of cortisol before? What have you all heard of cortisol? Yeah. You get your cortisol levels raised. What else have people have heard about it?
Infomercials.
What are the infomercials saying?
Say it's bad.
Say it's bad. Infomercials say it's bad. Has anybody else heard things like that? Cortisol's bad. Lower your cortisol. It's going to give you heart disease. It's going to give you diabetes. It's going to do all these horrible things to you. Is cortisol bad? So it gets a bad rap. It gets a bad rap the way that stress in general gets a bad rap. But here's the thing about cortisol. We need it to survive. We need that cortisol. It's really important. If we don't have this axis, we're done for. Cortisol is very, very, very important. What cortisol actually does, what its primary function is to basically go visit with the liver, and it basically increases your blood glucose. It increases your blood sugar. And this is pretty important. We'll talk about why that is in a couple of minutes. But it goes and it increases your blood sugar. And what's the big deal about glucose? Why do we want glucose? What's the big deal about it? Glucose is a major energy source. We get energy from a lot of things that we eat, but glucose, sugars are a really, really, really good source of energy. So we need cortisol. We need that glucose increased in the blood. We need that glucose getting to other organs in order for those organs to function. So cortisol is really important. And it's so important that, in fact, in the morning, shortly after you wake up, you get a big burst of cortisol. That's what this picture is showing here. So here's kind of morning time, big uptick in cortisol. With this big burst of cortisol, you get a big burst of, anybody want to guess what you get a big burst of? Energy, exactly. You get a big old burst of energy. That helps you get going on with your day. So cortisol is really, really important. We associate it with stress a lot of times, but it's not really a stress hormone per se. It's more of an energetic hormone that interacts with the stress response. So kind of keep that in mind. Now, I'm going to go back to our hypothalamic pituitary adrenal axis here. What's really interesting about this axis, so this whole talk is about stress, but it's also about animals too, is that most other animals experience the same process. They have this same axis in their bodies, and it works pretty much the same way in many, many other animals. So we see this axis being activated in birds, we see it in lizards, we see it in otters, you see it in ocelots, you see it in coyotes, you see it in snakes, you see it in all kinds of different animals. You might be wondering, what do animals have to be stressed about? What are they stressing about? Right, folks? What would an animal be stressed about? Well, I think another way to think about this, a better way to think about this, in my opinion, is what don't animals have to be stressed about? For instance, consider the rabbit. If you were a rabbit, what are some things you would worry about? Brooks, what would you worry about if you were a rabbit? People coming and scaring you off, yeah. Delia, you had your hand raised. What would you be worried about if you were a rabbit? Ooh, cats and dogs, yeah. Say again? Birds, yeah. Big birds, what else? Anything else? I'm sure we can think of a whole mess of things, yeah.
Sub-zero temperatures.
Sub-zero temperatures, yes, from the man who keeps talking about snow. So yeah, I mean, a rabbit has a lot to worry about. Some of these things we mentioned, some of them we didn't. You know, you've got birds of prey, you've got cats, you've got dogs, the coyote is sort of a dog, cars, lawnmowers, all kinds of things. They have a lot to worry about. There's a lot that is an immediate worry, a lot of things that could potentially end their lives. And so because of this, these things do, in rabbits, also activate that response, that same axis. So here we have stress activation again, we have cortisol release, but you might be wondering how exactly is cortisol related to stress? Where does that fit in with this? So before we really even get to cortisol, we're just going to kind of break the entire stress response down into its little parts. We're just going to break it down. There's different phases of the stress response, different things that happen depending on, when that stressor occurs, how near we are to it, things like that. It starts off with something called the alarm phase. Big, scary sounding thing, the alarm phase. It just sounds terrifying. The name is like, alarm. And that's exactly what it is. I'm going to take a little scenario here. Let's say you're done eating, the talk is done, and you're going to go cross the street, and you're looking at a text, and you're crossing the street, and you don't realize it, but a car's coming, and you look up, and what do you feel? Sudden panic. That is the alarm phase. That is the alarm phase being activated. It's also sometimes called your fight or flight response. Some people may have heard that before, the fight or flight response. What happens in the alarm phase, this is a very fast response. Within seconds of a stressor showing up, your alarm phase gets activated. You have production of a substance called epinephrine. Epinephrine, a lot of times we call it adrenaline. This is a more common term for it, adrenaline. Probably all of you have experienced a rush of adrenaline, whether on purpose or not on purpose, at some point in your life. Some people really like this adrenaline rush. I don't. But this is what gets produced in the alarm phase, in your fight or flight response. What epinephrine does, much like cortisol, is it causes an increase in blood glucose levels. It increases your blood sugar. So that's one thing that it does. But it has numerous other functions too. So epinephrine, it increases your blood sugar. It also increases your respiratory rate, increases how fast you're breathing. It increases your heart rate. It gets your heart pumping really, really fast. It increases your mental awareness. Kind of really start noticing what's going on around you. Lots of sensory enhancement. So we have enhancement of various aspects of our physiology, of what our body is doing. But it also kind of turns things down too. So we have digestion being shut down temporarily. Your digestion gets shut down. We have things like your immune response being suppressed. We kind of slow down on that, pump the brakes on the immune response. So if we take a look at kind of what's happening in this picture here, we're routing energy away from things like digestion, things like immune function. If you are trying to get away from a stressor, if there's some big scary car like running at you, you're trying to get away, these are things that are non-essential in that moment. We can set them aside. We don't need them. What we have, increased mental awareness. Where can I go to get away? Increased heart rate, more blood being pumped to your muscles. Increased respiratory rate, more oxygen being brought into your body to be brought to the muscles. Increased blood glucose, big source of energy. All of these things are working together to get you away from the stressor. That is what happens in the alarm phase. And I think this picture really embodies the alarm phase. I mean, the cheetah is focused, but look at that gazelle. Look at its face. It is not thinking about reproduction. It is not thinking about digestion. Every aspect of its body is being routed into get me the heck out of here. That is the alarm phase. Now, ideally, you get away from the stressor, or the stressor goes away, whatever happens. Ideally, that stressor ends and you can kind of go back to normal, ideally. But that doesn't always happen. Sometimes the stressor continues. Sometimes it keeps chasing you. Sometimes it just sticks around. If that stressor continues, if we go on with that stressor, what happens is we enter the resistance phase. We get into the resistance phase. This is where we start to see increased cortisol production. This is where we have our cortisol production. Now we finally see this hormone coming out. Now remember, cortisol increases your blood glucose, so that's its primary function. Whether it does it for stress reasons or not, it's kind of up to that. But it increases your blood glucose, but it also does these other functions that epinephrine did. So we have increased respiratory rate, increased heart rate, more sensory enhancement. We have toning down of digestion, toning down of immune function. So while the alarm phase, this is kind of a short-term response. It happens fast, but it ends fast. If that stressor continues, you need some sustained energy. And that comes here in the resistance phase. That comes from cortisol. This kind of sustains these energy levels, sustains this, hey, I need to escape feeling in order to push you onward so you can get away from whatever is your stressor. So animals can also enter the resistance phase, so some longer term stressors that might occur. We talked about rabbits. We've got predators of all kinds that eat rabbits, lawnmowers of all kinds that eat rabbits, cars of all kinds that eat rabbits. And those are a lot more immediate. Those are pretty short-term stressors. But animals can experience longer-term stressors too. So I mentioned that I study birds. And one stressor that birds experience, well, there's actually a couple in this picture. So from one end, we've got this adult bird here on the left-hand side, and it's feeding these cute little babies, but it takes a lot of work to feed your kids. You don't know if you're going to get eaten. You don't know where the food's going to come from. This is very, very stressful for a bird. We don't think about it, but it's very stressful for a bird to have to feed your babies. On the flip side of that, I mean, these babies look like they're just having a grand old time, but life is very stressful for a baby bird, especially if you have to fight with your siblings for food. That's probably where most of the stress for baby birds comes into play. And this is something that I've looked at a little bit in my research, looking at sort of early life stress in birds. Again, not something that most people really think about, but I do, because obviously I do. Not just in birds, early life stress is an important thing to think about in humans as well. There's a lot of research that's been going on how things like childhood poverty or things like unstable home life in your young years affect you throughout your life. So stress early in your life can have really long-lasting effects, not just for animals, but for humans too. And so stressors that baby birds might encounter, so not having enough food is one, so having to fight with siblings for food, things like that. Another stressor is being cold. So a lot of baby birds hatch in the spring. Spring weather is very unpredictable, and it can get very cold very quickly. So there's a lot of things that can stress out baby birds. I happen to look at number of siblings, how much sibling rivalry you have going on. And I did this research with a bird called the eastern bluebird. We don't see a lot of eastern bluebirds here in western Kansas. You might get a couple, but you see them a lot more if you get closer to Manhattan and things like that. They're a very lovely bird. And what's really cool about these birds is that they don't just go build their nests out in a tree. They build their nests in a little hole. And so you can put up nice wooden nest boxes like this one that this bluebird is sitting on, and it'll go in there, it'll build a nest. The eggs will hatch, the babies will come out and everything. And growing up in a nest box for a baby bluebird is pretty great. You are hidden from the elements, you're protected. For the most part, predators can't get you. I mean, sometimes they can, but usually you can't. Parents bring you food, you're pretty happy. But eventually you get a little bit bigger and it gets a little bit crowded and you need more food, and so do your brothers and sisters, and so you're always having to either fight for food or you don't get enough food and things like that. So I was kind of interested in looking at that. How does that family size or how does that brood size affect stress in baby birds? And there's a really easy way to test this. This is something that bird researchers do quite a bit to look at things like family size, brood size. So here we have two imaginary nests. We've got here on the left a nest with 5 cute little baby birds in it, and on the right a nest with 4 little baby birds in it. And what you can do is take a couple of those birds from the first nest and just foster them in the second nest. And the parents accept them just fine. They grow up just fine. So now you've got a nest with 6 nestlings. So you've artificially enlarged that nest. You've given them a lot of kids. You put a lot of kids in there. And then an artificially reduced nest. And this one just happens to have 3 nestlings in it. And this is exactly what I did for part of my research. I kind of changed the brood sizes, changed the number of siblings in the nest. And some of these nests I just left unchanged and just used them as a control. So I had some control nests in addition to this. And what I expected to find was that the kids over here in these really big nests would have very high levels of stress hormones. And the kids over here in the little nests would have low levels of stress hormones. That's what I was expecting. What I found was not that. So what I found was that there really was not any effect of brood size. And here I have a hormone called corticosterone. This is one I haven't talked about yet. Corticosterone is very similar to cortisol, does the same kind of thing. You can think of it as being the same as cortisol. So taking a look at this picture here, this graph, so I have cortisol levels here on this x-axis. I have the reduced broods. These are the ones that had just a few babies in them. The control broods had kind of a mix of babies. I didn't change the number, but it was sort of a mix. And then the enlarged broods that had 5 or 6 babies in them. And there was really no difference between any of these groups. It looks like there might be a little bit of a difference, but it's very small. It's not statistically significant. So there's really no difference here. So I didn't see an effect on stress hormones, but what was interesting is that I saw an effect somewhere else. I saw an effect on feather coloration. So birds that were raised, these little baby birds that were raised in nests where there were like 6 baby birds, these big huge families, were less blue in coloration. They were less blue in coloration. Why is that a big deal? Well, interestingly enough, the blue coloration on birds, and a lot of animals actually, reflects in the UV spectrum. We as humans don't have a very great visual spectrum. It's fine, but I mean, we can't see in UV. Birds can though. Birds can see in the UV spectrum. So that blue coloration reflects in the UV spectrum. So this bird, we look at it and we say, okay, it's blue. To a bird, seeing that reflected in ultraviolet light, it looks a lot different for a bird. And that blue coloration can carry a lot of information on, hey, I'm a really awesome bird, I'm great quality, I'd be a great mate, you should come mate with me, I'll take care of your kids, all this stuff. It has all kinds of information. That blue coloration, that very simple, beautiful color, carries a lot of information. And nestlings that were raised in enlarged broods with lots of siblings had less of that blue coloration. Now, whether or not that effect persisted into adulthood, I don't know. Baby birds will lose all of these feathers and regrow them when they're adults. So those feathers that were not as bright blue do get lost and they do regrow them. So, we can have some stress on the parents, we can have some stress on the kids. Another way that an animal might have kind of sustained stress or, be hanging out in the resistance phase is by being territorial, fighting for territory, being aggressive to one another. So here in this picture, we've got a couple lizards, and it looks like they're fighting over, I think, a picnic bench or something like that, which is probably as good a place as any to be if you're a lizard. Makes sense to me. So, being territorial, trying to find food. We've got a lot of squirrels on campus. They seem to be pretty well fed, but the ones that aren't well fed do get stressed out about it. They need to find food that takes a lot of work and it activates the stress response. And, kind of bringing this back to humans a little bit, but from a different perspective, whenever we handle an animal, and by we I mean people who study them, that activates that animal's stress response. Even just looking at an animal activates an animal's stress response. Pretty much a lot of things stress them out. And so a lot of times what happens is, okay, we are being around animals, or if we study animals, we're holding them, we're catching them, and that starts to increase their stress response. But interestingly, it can go the other way as well. Normally we expect that stress response to go up, we expect it to be really, really high, but it can go in the opposite direction. So there was research recently done on the Galapagos Islands. So the Galapagos Islands are off the coast of Ecuador there. And there's a lot of animals that live on the Galapagos, and one of those animals is the marine iguana. There's quite a bit of them there. On the Galapagos, they have many national parks. They're very well kept, very well maintained. But tourism is pretty high on the Galapagos. It's a big tourist location. And so what was found recently was that tourism on the Galapagos Islands actually dampened, it actually lowered the stress response in these iguanas. So they had kind of a lower stress response. Let that sit with you for just a second. They kind of had this lower stress response. What they think might be going on is with all the tourism, these animals may have gotten used to people being around. They may have gotten habituated. Now, whether this is a good thing or a bad thing, we don't really know. Is it good to have a lower stress response? I mean, you know, could be some bad effects of having cortisol too high, but if your stress response is down here and you've got an animal chasing you and you need your stress response to be here, it could be a real problem for you to have a dampened stress response. So we're not really sure if this is good or bad yet, but it is interesting. It's something that's a little opposite from what we would think it would be. So kind of going back to our favorite axis again, ideally, at some point, that stressor will go away and we have basically a stop to this whole thing. We kind of shut down this whole axis until we need it again, ideally. This is meant to be a short-term response. It's not meant to be long-term. It's not meant to be super long-term. But we, especially humans, experience long-term stressors. We experience long-term stressors, and they come from everywhere. If we have a stressor that lasts for a long time, this could be many days on end, many weeks on end, months, years, a continual stressor, or it could be a stressor that's short, but it happens every day for weeks and weeks, months and months, and so on. What happens is we enter something called the exhaustion phase. The exhaustion phase. This is where we don't want to be. We don't want to be in the exhaustion phase, but a lot of us spend our time in the exhaustion phase. I am sorry to say, dear humans, we spend a lot of our time in the exhaustion phase. What we have here in the exhaustion phase is continued secretion of cortisol and epinephrine. Continued secretion of cortisol and epinephrine. Our bodies were not made for this. They were not made for continual secretion of cortisol and epinephrine, but that's what happens in the exhaustion phase. This is where we have something called chronic stress. And with the continued secretion of these hormones, we have continued effects. Increased blood sugar, increased respiratory rate, increased heart rate, shutdown of the immune system, all these kinds of things. So, stress itself is not bad. We've seen stress be important to get animals out of situations where they are literally going to die. So stress itself is not bad. The problem is when it occurs out of context, there's no immediate threat to your life, it occurs out of context, and when it is chronic. Chronic stress is bad. Now, if we take a look at our short-term stress responses again, we had all these effects: increased heart rate, increased blood glucose, increased respiratory rate, decreased immune function, things like that. These are very important when we're facing a stressor. These are the things that are going to get us away from that stressor. That is why this whole process evolved. It evolved in order to get us to escape a stressor. We were not meant for long-term stress. No animal's really meant for long-term stress. With chronic stress, these things that were so helpful before can become problematic, and this is where we start to see health problems. So that increased heart rate can lead to heart disease. Increased chronic blood glucose, you guessed it, that can turn into diabetes. Shutting down the digestion can lead to irritable bowel syndrome. Reduced immune function can end up with chronic sickness potentially. And that enhanced sensory function can lead to degeneration of neural tissue. So when we experience chronic stress, it usually manifests itself as health problems, as illnesses. When animals get to this stage, they usually die. Most animals do not make it to this stage. Stress is not meant to be a long-term sustained thing. It's meant to be a short response, a short-lived response. So most animals do not experience chronic stress. But there's one animal that actually does experience chronic stress, and that is the baboon. Baboons experience chronic stress. So they experience chronic stress. The reason why they experience chronic stress is because a lot like us, they tend to invent stress. They tend to make things more stressful than they need to be. This is something I do all the time. Baboons are interesting. So they have a very complex social hierarchy. There's dominant individuals, and these individuals usually get the food first, they get the mates first, they get all the napping places first, and the subordinate individuals don't really get that. And what's interesting about baboons is they don't have very high energetic needs. They can maybe spend a couple hours a day eating, and then they spend 9 hours just lying around, inventing stress. We think back to the rabbit. The rabbit's got a lot going on in his life. Rabbits have pretty high metabolism, so they need to eat a fair amount. And in order to get food, they have to go out and potentially get eaten. So they've got a lot going on, but they don't have a very complex emotional side to them. Rabbits are pretty, they're pretty simple. But baboons are not. Baboons are very, very complex. And so they have all this free time. And this is one animal, it's really unusual for animals, but this is an animal where a lot of their stress is purely psychological. So for instance, you might have a baboon who gets really agitated because his biggest rival is taking a nap 90 meters away. And this is getting his stress response really activated. So this is not an immediate threat to their life. It's not even a kind of immediate threat to their life. It's not anything. It's purely inventive stress. And we kind of do this too. We have stressors. They are important in our life. Things like money and food and work and things like that. So they are important, but they're not an immediate life-threatening stressor. So it happens a little bit out of context in our lives. So baboons experience chronic stress a lot like we do, and they pay for it in their health. Interestingly enough, you can have baboons with heart disease. You can have baboons with chronic high blood sugar. You can see these health effects in baboons. It's really unusual and really interesting. But what seems to save the day are social interactions. This seems to help baboons. So baboons who spend more time grooming other baboons or being groomed by other baboons, baboons who spend their time playing with little kid baboons tend to have lower stress levels. They tend to have lower stress levels. It kind of saves them. And the same is actually true for people. There's been research that has been done that shows that when we interact with people, when we spend time with people we care about, when we even have physical contact with people we care about, that lowers our stress levels. So we can learn actually a little bit from baboons, from how they get stressed out to how they kind of feel a little bit better. So I guess the thought I want to leave you with today, the final thought I want to leave you with is that stress is not bad until it is. It's not bad until it is. It's not bad until it gets chronic. That's when we have a problem. So that's pretty much it. I kind of end my talk on sort of like an sort of feeling. And I did try to pick the least stressful picture I could possibly find to end on. I want to thank you all again for coming. Thank you to SMEI for hosting this event. If anybody has any questions, I'll be happy to take them now.